Awesome. Thanks so much, Guy. I appreciate the opportunity to talk about bioremediation and the work that we're doing here in Alberta and abroad. But before I get started, just a big shout out to Guy and Ian and the rest of the team for the opportunity. Our technology has been featured in one other chat on here, which is where I got introduced to Guy. And I think this is just a great asset for us to have in our industry as far as a education model. So I'm Robert Lacey. I'm the founder and president of Delta Remediation. We're based in Edmonton, Alberta. I'll get into a little bit more about Delta as we go, but I'm actually not a technical person. I've been doing environmental work for over 10 years, so I have the designation of an environmental professional, but my degree is in business. But like I said, I have been working with microbes for over 10 years, so I'm pretty confident in the work that we're doing. So what makes us get up every day and go to work? What we do is very unique. It's very challenging. We are sort of in a David and Goliath battle against the landfill, really. When I discovered that most remediation in Alberta was dig it up and truck it down the road without any actual remedy being applied, I figured there's got to be a better way. And so, given the direction of industry and society, we noticed that bioremediation was not very well represented in Canada. And so we wanted to bring Bioremediation 2.0 back into the environmental landscape in Alberta. So just quick outcomes for the day. A bit of bioremediation introduction, a bit on Delta. We did a bunch of work up in Churchill Marine Tank Farm, which is what this presentation is about. We talk about some of the logistics, some of the techniques deployed on site, what's next for that site, and then we have a little surprise, hopefully at the end if we have enough time. So bioremediation is defined as the use of naturally occurring or deliberately introduced microorganisms to break down environmental pollutants. Here at Delta, we're actually doing both. We're deliberately introducing natural species that are cultivated on site and then introduced into the soil or groundwater. Within the field of bioremediation, there's really two kind of camps. There's one camp that believes that the bacteria are there. I mean, bacteria are everywhere. They're all over us. They're all over every soil particle. And then the other school of thought is bioaugmentation, which is actually adding exogenous or outside microorganisms into a site. And that's what Delta specializes in. Although we do employ pretty much all techniques that are used in biostimulation as well, aeration, the use of nutrients, the use of surfactant, enhanced bioremediation, all these different things that are used in biostimulation are incorporated with the proprietary bacteria and then introduced. The work that we do is primarily aerobic, so we like oxygen, our microbes like oxygen. However, they are able to survive and thrive in low oxygen or even no oxygen environments because they are facultative, which means that they're not anaerobic. They can basically switch between both. So our species are primarily aerobic or facultative species, and that's I can't really speak to anaerobic bioremediation, which I know is certainly a thing in the industry. So why do we feel that bioaugmentation is necessary? Have been using this quote for a while. I actually tried to find out who it was, but you can use natural yeast in making bread or making beer, but you're not going to be able to control the outcome. And we feel the same applies to bioremediation in fields. So I have this nice little signature from Sam Adams about using commercially available yeast to control the outcome. So we look at it the same way. If you add specific hydrocarbon degrading bacteria, you're going to see results versus just hoping that the right ones are on site naturally. So within the field of bioremediation, there's really three components that we utilize. The microorganisms themselves, typically species of bacteria, are what's utilized in bioremediation, although there is an emerging field of mycoremediation, which is using fungi. And then archaea is another single cellular organism that is used in remediation, although not as widely as bacteria. Nutrients are used for terminal electron acceptors, as well as building strength in the cell wall of the bacteria. And then surfactants are used not necessarily to improve anything on the microbiology side, but to improve things on the contaminant availability, to help in the distribution of the microorganisms throughout the soil matrix, to help sort of release contaminants from the soils. I'll get into that a little bit later. So Delta's, like I said, based in Edmonton. Our background is actually in heavy equipment and machinery and industrial recycling. So this machine that you can see here is a concrete recycler. So I started recycling and concrete and diverting waste from landfills back in like 2010. And this work sort of exposed us, like I said, to the bigger issue in Alberta, which is the Class 2 landfill epidemic, I say, and the need for alternative strategies for handling contamination on site. And so with that, we got it into the bioremediation business. We've been doing it for 10 years. We have projects in Nigeria and Kenya. Currently, we're working in Kuwait. But we're very, very dedicated to building the business right here. There's lots and lots of good work for us to do in Alberta, as well as across Canada. We do work in most of the provinces. We're looking to get some more exposure into the maritime provinces. So if there's any interested parties in the Maritimes, I'd love to hear from you. Yeah, a little bit more on us. So we're an interesting company in the fact that we have developed technologies. Biologics 2XP is a microbial consortium that's exclusively manufactured for us and our clients. We do take our own products and do field services, and we also do sell our products to qualified applicators who understand the sort of the do's and don'ts of bioremediation. And I will acknowledge, bioremediation, has that affiliation to snake oil. There have been lots of failures that we've seen over the years. And one thing I'll say is that if it sounds too good to be true, it probably is. We hear things of bioremediation products that work on hydrocarbons and salts. Well, that just doesn't make sense from a chemistry perspective. Products that can be sprayed on the surface of soils and work, meters or feet down without knowing the soil type. Obviously, if it's cobble, that would work, but in clay, you're not going to get, inches, let alone feet or meters. So it is an interesting model in that we take our products to the field, we work with them, we provide feedback to the developers, and we're sort of continually developing our process. It's never at a status quo. We're always redeveloping how we do things. So jumping into a little bit of background on the Churchill Marine Tank Farm. So Churchill's an interesting community. Obviously, it's on Hudson's Bay. It's in northern Manitoba. There's a challenge in logistics, which I'll get into a little bit later. There's no roads to Churchill, so it's either the train or the plane. And Churchill really exploded I think it was the 1920s actually, where they built this big grain farm, this big grain silo facility, and they shipped grain out of Churchill to European markets for years and years or decades. And as part of that, they needed fuel for the ships, so they developed this tank farm. And it's kind of hard to tell from perspective here, but I mean, this is a huge area. This silo is massive. I did a little bit of quick math here with our friend ChatGPT to try and figure out what sort of storage volume they actually had. And I've been to site. These are 120 feet for sure diameter storage tanks. If they're 10 meters tall, that gives us 10.5 million liters per tank, and there was 4 of them. And so, yeah, massive amount of storage, lots of pipelines to pipe the fuel from the tank farm over to the port, and also to support the Churchill town itself. And so this is what it looked like, back in the day before decommissioning. And there's a few other pictures that I'll get to later that show what it looks like now. There is still a tank farm now. So the tank farm still does serve the community of Churchill. So they have jet fuel for the airport. They have diesel fuel for, different operations that are around town. And they have gasoline for all the quads and vehicles that people drive. So the tank farm's a much smaller now than it was. Just for quick reference, you can see this little shed here. This is actually our bioreactor as well. But on this one here, this little shed is right here. So this area here is where the tank farm is now. It's much smaller, but I believe it still has about a 50,000 liter capacity for petroleum storage. So a little bit of history. So pre-1970s, it was constructed to support fuel resupply for the Arctic. Into the 1990s, it was just, normal operations. Obviously, there were some spills. We heard whispers from town folk that, one of the big tanks released one day. I wasn't able to verify that, so that's an off-the-record statement. But there certainly were lots of historical hydrocarbon impacts in the soil and groundwater. In 1997, a baseline study was done confirming all of that. In 2010, they started to look at the future of the use. In 2018, Arctic Gateway, who is our client, purchased the property for redevelopment and remediation. We got involved in the project in 2022 with on-site operations, and over 2022 and 2023, we've treated approximately 3,600 cubes of contaminated soil and groundwater at the site. So this is a diagram of sort of what we were walking into, with the red lines being areas of concern. So these are all you can see the bottom here. This is the low-lying area of these tanks. These are all lined. We're lined for protecting the environment. And so, obviously it's still a concern, and remediation was required, but less of a concern here versus some of these other areas were not lined, and we had hits on the groundwater monitoring wells that were just off-site. And so that was the biggest concern with the province, was these off-site migrations. And so our soil treatment always had that, groundwater in mind. And luckily, when we got to site, um, actually, this isn't a great picture, but when we got to site, we realized that the groundwater was actually a lot higher than we had intended. And well, this is a good site showing sort of post decommissioning and pre-remediation. We're starting remediation in this area here, and you can see these are all the lined cells that had water. And these two cells we'll reference later. We had to actually use these as containment cells for some of the construction that went on. So some of the challenges with implementing a remote bioremediation program, it's to get gear up there. You had to drive to the train in Thompson, and then it's a 16, 18-hour train ride to get up there from Thompson. Separate train for people than equipment. And so, yeah, it's multiple days, almost a week to sort of, by the time you get from Edmonton to Thompson, Thompson to Churchill with all your gear, it's certainly a big thing. The plane obviously gets you there quickly, but the flights to the north, to Churchill, like many northern communities, is very expensive. And other on-site considerations, we did hire a lot of locals, which was great. We got to learn a bit more about the community and the culture, but it did come with its own challenges. And we also worked with a lot of local equipment. So the heavy iron that we used for doing the soil mixing was locally procured. And then, of course, with the site being decommissioned, we didn't really have a lot of power. There were a couple areas that had power, but we did have to have remote power, and we did utilize remote sources of water for this remediation program. So in 2022, we had planned on our normal processes to do basically windrow ex situ remediation above ground. Once we started digging into the soils, groundwater was like a foot or two below the surface of the ground. So as soon as we started digging and mixing, we basically just made mud. And so we shifted our program from being an above ground ex situ program to an in situ soil mixing program, where we essentially mixed the soils with the bioremediation amendments in place, and we tracked every day's progression with basically tank dipsticks, and we had a Trimble GPS to sort of allocate which areas have been treated. And soils management is a really big part of the program. We also put some measures in place to protect the different waterways from the site excavation and site works. So we did a bunch of that. So this is our bioreactor, and on certain days when the cell mass went into an exponential growth phase, you'd show up and you'd see this biofilm or biofoam sometimes on the ground from the tank itself. And these are plastic tanks that were sourced locally. We cleaned them as best as we could. But working with local water sources, working with outdoor environments, things do get dirty. And one of the things that we learned on this site was that the bioreactors, needed to be changed. If we went for too long, we would essentially have a fouled culture. And so we needed to basically stop, switch to a new reactor, clean the previous reactor out, and then run it again for 10 to 14 days. This is one of the local Indigenous people that we had working with us on this program. And we did have a lot of, spectrometry type tools that allowed us to do the different analysis of the bioremediation amendments that we were cultivating on site every day. Part of the 2022 program, especially to identify the groundwater issue, was on the south-facing aspect of the site, which was down gradient for most of the contamination. We built what we called the biological treatment trench. It was 175 meters long. We had our biologics culture, and then we had surplus media from some water treatment that we were doing. So organoclay and carbon filter media were added into this treatment trench. And we also used a bunch of old wheat husks that they had over at the silos. They were doing some work over there and cleaning out the silos, and just as some additional organics to add into the mix. So we did work with some, you call it compost material as well. This is just quick showing the treatment trench and some of the different monitoring wells. You can also see in cell 3 and 4, the material that's in there now actually came from underneath of this railway. So in 2022, simultaneously as we were doing our remediation up here, they were doing a construction project for a new rail spur. And so a lot of that material had to come out of there and come into somewhere. And so we used these two cells. And as the soil was coming in, it was getting bioremediated, but the very, very heavily impacted soils that came out of that area. In 2023, we knew that there was groundwater issues. We knew that there was a lot of material that wasn't excavated and transferred into the cells. So we did an in-situ program to address contamination underneath of the rail spur. And so there was 106 of these metal wells that were installed. These wells are not for monitoring, so we wanted something that was more robust, that could withstand the Arctic environment and some of the shifting, and also just the operations. One of the challenges with this site is that we've had lots of groundwater monitoring wells that have been damaged over the years. And so we wanted to have something that was a bit more robust on this site. So like I said, we installed 106 wells laterally north of the rail spur. So meaning the groundwater would flow through this kind of, again, a treatment trench or treatment area. We had a well ID for each log, and over the course of I think it was about a month in the summer of 2023, we injected 185,000 liters of biologics into the wells. Each well had a target of 1,700 liters, but we never went over 600 liters per day. There were 3 wells that basically were rejects. They didn't accept much material. But we just added more to the wells on either side of them so that we had, as even of a distribution as possible. And they're very low pressure in these wells. So we're low and slow and working under very low pressures. So this is, I have to say this is based off of pretty limited data. The consultant on this site, wanted me to preface that a lot of the results that we're seeing are sort of preliminary results. But there was a bit of a soils comparison that was drafted. And, we see, in some cases a 0% decrease, but in other cases, 80%, 50%. So overall, I think it's fair to say that there's a good trend, that things are moving in the right direction. We were on site this year and we did do a little bit of test pitting, and it does look like some of the further down materials need to be remixed. And so that's one of our proposals for next year, is to do a bit of a soil remix in those 2 cells where all that excavated material went. Groundwater is even a little bit more murky, I'll say, as far as the data goes. We had very limited data going into the project. We have one exceedance at monitoring well number 7, and but we did meet guidelines at a lot of the boundaries, which is good to see. And we did see on my next slide, I've got some notes. We did see that in F2 for monitoring well 18, offsite prior to treatment was 400 milligrams per liter in 2020 and 3.6 milligrams per liter in 2022. So very drastic reduction there. And then F2 at the south fence side was still pretty bad in 2020. With in 2020 it was 10 milligrams per liter and 2.5 in 2021. So definitely seeing a pretty drastic reduction in the groundwater space as well. Also seeing that, we don't have elevated levels of nitrates, so that the bioremediation amendment, the nutrients were not overdosing. But we did see a little bit of low phosphate. So considering doing, an additional nutrient-only injection as part of our 2026 work plan. Chloride's not really an issue here because of the closeness to the marines. There were some chlorides that were seen, and same thing with background metals. So on the water side, basically a continued monitoring program, maybe an injection of nutrients into that rail spur area again, and definitely more data to be collected. So in 2025, we did a small remediation program at the former pump house area, and the consultant was up there doing additional sampling. I haven't seen the new data yet, but it should be coming shortly. In 2026, we're looking at doing a bit of a larger program focused on remixing some of the hot spots in those 2 cells that I showed you, and also doing a nutrient injection under the rail. And then beyond that, we look at ongoing sampling and monitoring, which we're not a part of. Um, and I think I'm doing a little bit, I'm probably decent for time. That was probably actually about 20 minutes, which is not bad. Working in Churchill, we got the amazing experience of getting to work around polar bears a little bit. And so, we always had bear spray and bear bangers and stuff like that on us. But in this instance, we got to see a polar bear, and this video is showing a problem bear being tranked. So I'll just quickly play this and then carry on.
No sound on this video, right, Robert?
Okay, sorry. If it's just the sound of a helicopter, anyways. But do, you can imagine.
Okay, no problem.
And I think that this at this point in time, the bear actually had been tranked. But one of the wildlife officers, saw us videoing across the fence and said, "Hey, how quickly can you guys get over here? We need your help." And so obviously we said, "Right away, ma'am," and we all jumped into the truck and we got outside of the site and went over to where the polar bear was. And what they needed help with was loading him into the truck. What they do when they get too close to town is they tranquilize them, load them into a truck, and they actually have a polar bear jail in Churchill where the polar bears go. And so me and my team helped load him up. There was 10 of us that lifted this guy. Apparently he was 970 pounds, and they had a specific sort of stretcher, I guess, for the bear. So the first thing was getting him on the stretcher, and then the next thing was getting him into the truck. They did let us take some photos with them, and the weirdest thing is when the polar bears are tranquilized, they still blink. And so it was pretty freaky to see him blink, knowing that he's still alive. He's just having a bit of a rest. And so, yeah, they let us take some selfies and they loaded him up and off to polar bear jail he went. And that concludes the presentation. So I hope that you learned something. I feel like it was a little bit fast. If you're interested in bioremediation, I absolutely love talking about it. And I would welcome a one-on-one with you, or if you'd like to do a lunch and learn for your team, we do virtual lunch and learns almost on a bi-weekly basis. So please do reach out, and happy to answer some questions here as well.
That's awesome, awesome, Robert. Uh, that polar bear in the back of the pickup, that's a classic. That should be on a lot of people's screensavers. It's an
Yeah.
awesome picture. Thanks for a great presentation. We've got a bunches of questions that have come up here, but me being the host, I get to start off. So I'm going to start off with a question comment thing, and it goes right back to the beginning where you talked about bioremediation versus going off to the landfill. And I'm not sure about Alberta, but I know certainly in Ontario and BC, we have excess soil regulations now. It's just it's there's a move on to think twice before you take your dirt and send it off site to a dump. Reuse, recycle. Don't send clean dirt to the dump, but if the dirty dirt can be remediated and whether it meets standards, numeric or risk based, as long as it's environmentally safe, that's the key. Why not look at bio? So what do you see about the future of your business, Robert, and this concept of reusing soil?
Yeah, I think it's great. I mean, I think we always say that soil should be kept not only in the ecosystem but also in the economy. Soil is worth money for projects, and it's something that we shouldn't just throw away. If you look at the 3 R's or the 4 R's or whatever, it's reduce, reuse, recycle. Landfills at the bottom of the line, and it seems like a lot of times, especially here in Alberta, landfill is just top of the line because it's easy. Just because it's easy doesn't mean it's right. We are building a toxic legacy here in these with these landfills, and so I welcome that type of legislation. We are working right now on a mobile ECA to have our product applied in Ontario because of the regulations they have there. We're already doing a lot of work in BC, so I welcome those regulations. I think that even at a minimum, if you want to landfill soil, I think that they should be charging a tax or some sort of a fee that goes into a slush fund that's eventually going to be, required when those landfills do need remediation.
Great. I agree. Interesting. Again, I'm going to ask one more question. It's maybe already been asked by others too, but I take it one of the main drivers that for you in Churchill was to stop offsite migration as opposed to you weren't trying to turn the soil back into pristine pre-development conditions, right? So So on the offsite, you mentioned that most wells remediated, but you still hadn't most had, but there's still some work to be done.
Yeah.
Is that fair? And do you see a challenge in actually stopping the offsite migration, or do you think there might be a need for some kind of physical containment at the end of the day after going through this whole process?
No, I mean, we've already seen drastic reductions in groundwater even after year one. We're actually technically in year three now. So there have been new samples that have been taken. So we'll we'll know a lot more in weeks we analyze samples that were taken this year. But we've already seen major reductions in offsite, and I think there's only one well that still had some offsite. So as far as regular plastic, a neighbor curtain or, maybe infrastructure that's proposed at the time. Said adding some additional nutrients into the groundwater just to help the microbes flourish is part of our sort of recommend for 2026. But yeah, we're really seeing things trending in the right direction.
Interesting. Someone's asked this question, and I also have the same question about you're so close to the ocean. Salinity. I got a salinity shallow table, saltwater intrusion. Did high salinity affect some of your bioremediation processes or
It's a
or
great question. We have salinity data. We didn't really necessarily obviously we didn't consider it as a contaminant of concern because of background. The levels that we saw, we weren't overly concerned with. We have done quite a bit of work. It's called halo-tolerant species, which means salt-tolerant bacteria. A lot of the materials that we're working with overseas in Kuwait, when they had those fires, they used seawater to put them out. So we have elevated levels of chloride. We've grown bacteria in 60,000 ppm water, so more saline than ocean water, and their growth curve slows down, but they still grow. And so while it was a concern, it's not something that we could really do anything about. So it wasn't a major concern, but it's definitely something that I guess we've done some research in the lab to overcome that challenge because we've seen it in other places.
speaking of Kuwait, so someone's asked, and I think all these questions are great. Um, you said you've worked in these MENA countries, Middle East, North Africa. It sounds like getting to Churchill is a real technical logistics challenge, but I gotta imagine it's a challenge getting over to Kuwait as well. Uh, what are some of the big differences or similarities in working in those environments?
Yeah, it's there's definitely some cultural things. I myself haven't actually been to Kuwait. We have two staff members that have been on two journeys, and one of the guys, he wears a nose ring, so he takes his nose ring out when he goes to Kuwait because it's not really seen well, I guess, there. So he
Interesting.
wears his nose ring when he's in Churchill. But yeah, it's certainly some challenges. In Kuwait, we're dealing with a heat challenge, which is, I believe, more of a challenge. When bacteria get cold, their metabolic rate slows down. When they get frozen, their metabolic rate slows down to basically nothing. So we don't see a lot of biodegradation happening over winter months, but we do see the bacteria come back in the spring and continue to degrade. So they don't die off. However, in Kuwait, the temperatures get into the 60s, and we've done some high temperature testing on the culture as well, and that it does stress them out for sure. Into the 60s, it's well known to kill bacteria off. So one of the big differences between Kuwait and Churchill is that we've got the heat, which I consider to be more of a challenge because if you kill your bacteria off, you're going to need to redose, and obviously there's an expense that comes with that. Versus if it's cold, you could do things like just remix the soil again or just add some nutrients. And so you're a little bit more limited in those hot countries. Plus, obviously, there's the human health and safety of working in those temperatures.
All right. So a question again, the same question I have, it has to do with the amendments. You said there's something used called biologics. Um, does and well, a couple issues around that. I assume it's allowed to inject some strange mixture into the subsurface. Is this something I don't think I can go to my local pharmacy and buy a bucket of biologics bugs. Is it proprietary or is it available? What's in it? Is it just nutrients and a culture of bacteria? Are they spore formers, that kind of thing? And And then a broader question. Um, how do you know it's working better than the local the local bugs? Like, do you actually ever go and test numbers of your consortium of bacteria that you added versus the native and see if it's doing anything? Or is that
Yeah,
all stuff you did in the past?
yeah, good questions. There's a bunch there. I hope that I can cover them all. So Biologics 2XP is a proprietary formula of bacteria that we have created at Delta Remediation. It's
Okay.
not available at PharmaSave, but it is available at Delta Remediation. That being said, we don't just sell it to anybody. Bioremediation has been oversold in the past, and so we want to make sure that we're selling to parties that understand geochemistry and how things work, and that they're not going to just go and spray it on the surface and hope that it works in the middle of their pile. So um, basically qualified applicators can purchase product from us. And it is a consortium of sporifiers and non-sporifiers. So we do have some bacillus that are sporifiers, but primarily we work with Pseudomonas species, which are non-sporifiers. There are no nutrients in the product itself, in the 2XP product. We have a separate product called Biologics Nutrients, which is a specific nutrient for those bacteria in our consortium. But we keep them separate. Nitrates can burn bacteria, and so you don't want to have them in the same storage container. The microorganisms that we work with, we've worked with a number of different carriers over the years. Bentonite clay as a carrier, some different soy carriers. And we found that solubility was a factor. And so we've actually been working with dextrose as our carrier in 2XP since 2018. It has a high solubility, and it's also a carbon source for the bacteria when they're growing in our bioreactors. So I think I covered most of your
No,
questions there.
that's pretty cool. Well, what you didn't say, how do you know it's working better than the
Okay.
local?
Yeah.
I mean, up Churchill as an example, I think you said it yourself. I mean, for decades of hydrocarbons in the subsurface, the bacteria that are there are probably all adapted to munching on this stuff. They
Yeah.
probably they've probably been doing it naturally, just not at the enhanced rates that you're looking for, right?
Yeah, we're applying bacteria in populations that are orders of magnitude higher than background populations. So it's not a question of if one bacteria that's natural or indigenous versus exogenous. It's also just the sheer mass of sheer biomass that we're introducing into these sites. I mean, we wouldn't be doing what we're doing, and we wouldn't be seeing the success that we're seeing if doing nothing was the same. People would never hire us; they would just do nothing, and their problems would go away. On this site specifically, there are, data points from 1997 where we can see that hydrocarbon levels are at a certain level, and that into the 2020s that there hasn't been much degradation, and then all of a sudden we see 50%, 80% drops. What was different that was done in 2022 versus 2019, and that is bioaugmentation. So I think the results speak for themselves. And certainly, biostimulation has a place. Um, but I think that again, to get the kind of results that we're getting in extreme environments, adding specific bacteria allows you to control the outcome.
Okay. Interesting. That's a really interesting explanation about what's in the biologics mixture.
And
Actually,
and
I hadn't really appreciated the additives and the nuances of finding the right mix.
And as far as the approvals go, I did want to note too that in Canada we have what's called the domestic substance list. And the domestic substance list is a federal list of chemicals and biologicals that are federally approved by the government of Canada. And every species that is in our consortium, every aspect of chemistry that's in our nutrients are all DSL approved. So we don't actually need site-specific clearances to do bioaugmentation. The products are federally approved. Obviously, if there's a municipal or provincial regulator that wants to talk to us, we're happy to talk to them. But, we've done work specifically for Environment Canada as an example. And once they understand that we have a super high quality assurance program, every batch comes with its own QA QC data to ensure not only the viability of the product and efficiency, but also that it's pathogen free. So our QA QC is of the highest standard in the industry. There hasn't been a country yet that we've been unable to get an application approved in, Australia being the hardest They're very, very weary of exogenous microorganisms coming into their country. They've had lots of issues with pests, and so yeah, they definitely make us go through the runner. And we did get it across the line in Australia as well.
Interesting. Well done. Hey, I forgot to mention to people that 10 minutes ago was the bottom of the hour. We try and keep everything to a half hour, but we're already 10 minutes past. We're going to go with another few questions. We've got tons of questions here. Just so you know, I'm going to be passing all your questions on to Robert directly, and he can get back to you one-on-one with answers. I'm sure that's okay with you, Robert. Um,
Absolutely.
because we're not going to get through them all here. But they're all good and they all lead to a really interesting discussion. I mean, I'm hyped up about this. I mean, I got my microbiology degree in 1976, and I've been dealing with bacteria and environmental microbes ever since. So that what you're doing here isn't new. Um, but what happened was in the early 90s, people just the consultants remediation departments kind of shrank. People backed away from in situ everything, at least in the West. And I'm hoping we can bring that back. And it may come back because of legislation which says we've got to start looking at reusing and sustainable solutions. So that's kind of exciting. Uh, Someone here has asked, well, there's a bunch of them. I'll just pick a couple at random because we got to get going here. Um, what about contaminants like tetraethyl lead showing up from the gasoline releases? Any PFOS or PFOA showing up at any of your sites? Have you run into that? Is that becoming a problem?
Yeah, we haven't come across PFAS on sites. I mean, I'm interested in the topic. I've wanted to apply our process to PFAS impacted soil or water to see what impact, if any, it has. So I can't say though. The first question about lead, there was you said a bigger term, but we do see lead show up from time to time on sites. And it depends on the site and the regulator. Inorganic contaminants do not biodegrade, so doing bioremediation isn't going to break down the lead. However, usually the lead is a little bit less of a concern as long as there's not, pathways for influence and impact. So we either see the lead sort of get exonerated, I guess, as a contaminant of concern if we can control the hydrocarbons and the lead still may exist. Is that acceptable? And that would be something that we would determine with the client and with the regulators, obviously before going and doing any work. But one of the byproducts, or sort of call it externality of doing bioremediation, especially in situ soil mixing or ex situ bioremediation, is that some of those parameters, like say lead, that you have a hit of here or there, they are going to get mixed out. When we're doing the soil remediation, we are adding the amendment, and distribution is an enormous component. I'm always a proponent of saying how you do the bioremediation is equally as important as to what you do it with. So just having this great product doesn't mean that you're going to have success. You need to know how to apply it. And distribution is a main aspect of that. If you don't have the contaminant connect with the remediation solution, whether it's an oxidant or a biological or whatever, don't expect results because there's nothing happening there. And so we do need to mix the soils very, very well. When we do mix the soils, typically those little hot spots or blips of lead go away just because we're mixing the soil. So it is site dependent, and a very good question.
Interesting. I'll just go one more question there, then we're going to wrap up because we could go on all morning here. Um, um, when you talked about mixing, here you are in Churchill, shallow water table, but if the contamination had gone deeper, it would be what would you do with it? Like, and you add in tidal effects next to the ocean, saline water, sloppy. Um, any thoughts or
I mean, I guess one thing that I always, need to remind people is that the contaminants that we're dealing with didn't originate underground. They originated above ground, and through gravity and, normal processes, they ended up where they ended up. And so by doing manual injections and doing in situ soil mixing and trying to get, distribution of these products into the soils, we're going to see some of those same sort of percolation effects that ended up getting the contamination there in the first place. And so There are some sites that we do where access is very limited and we're, flying in with helicopters. And, one of the more basic techniques that we have is, looking at what the original release was, say it's 2000 liter, or sorry, a 200-liter drum of petroleum. We'll come up with some formula of 400 liters or 2000 liters of biologics and essentially recreate that spill. It's not the most effective way to get product into the ground, but it is a technique. And so I would say that anything that we're doing to manipulate the soil is sort of helping to get that down further. But yeah, we're talking about bedrock, and we don't have a ton of experience working in bedrock scenarios, but we would just look to bring in a hydrogeologist, look to bring in somebody who has the right type of drilling equipment. And if we wanted to get deeper, we would put a more complex injection gallery in using some sort of a hammer drill to create those wells.
Okay. I think we're going to wrap up there, Robert. Thanks for a great presentation. I'm going to end up with one comment from one of the audience members wonders if you managed to get some polar bear kisses in there with that polar bear. You don't have to answer that, but
Yeah, I would have that would have actually been a pretty cool selfie. I got a selfie sort of right beside him, but giving him a little smooch would have been one step up. So maybe next time.
okay. Thanks, Robert. We look forward to having you back again in the new year. I'm sure you've got lots of case studies, and this is fascinating to look at some of your other sites.
Absolutely.
Thanks again, and thanks everybody for joining us. Um, I don't know how much I could say this, but in a little over 1 hour, we're starting our emerging professionals webinar on groundwater sampling, all the tips and tricks and all that. I encourage you at the last minute to sign up uh, and join us for that session. And we look forward to seeing you next week with another talk. Thanks again, Robert. Bye bye, everybody.
Thanks, Guy. Take care, everyone. Have a great day.